Well, thank you for inviting me. I'm glad to be here. I want to talk, I want to talk about a project that I've been working on really now for about 2.5 years. Probably going to end up working on it for at least another 3. Which started really with a recognition at the university level that when we look at the amount of research dollars that come into the university, I think Florida State gets somewhere in the $250 million a year in new research dollars every year. That puts us actually a long ways behind some of our competitors, University of Florida, University of South Florida. And the biggest, at least within the state, and the biggest difference is that both of those have a large amount of health-related funding. Related to partially the fact that they have working hospitals on their campuses and their medical schools are associated with a working hospital, and so they can, sorry, somebody wants money. Let's see if I can turn this thing off. The problem I have is I'm using this multi-factor authentication system that the university has as a test, and so I always have to have a working cell phone with me in order to get that to work. But anyway, so go back to the story. University of South Florida, University of Florida both have large medical facilities, large medical schools that generate anywhere from $300 million to $400 million a year in research funding for health-related research. FSU, with a new program in the new College of Medicine that does not have a teaching hospital here, hasn't really developed the infrastructure and the amount and quite the research effort that that those other schools have. Although it's been growing very fast, and I think last year they brought in something like $60 million in new research money through to the College of Medicine, primarily through the National Institute of Health. The other group that has been growing very, very fast in terms of research and health-related research has actually been social work, all around behavioral health and all of those issues. Our Communication Science and Disorders program is also very, very active in research, that primarily funded by the NIH, and so that has also generated a lot of money over the years. The School of Information is beginning to generate money through the National Institute of Health. So there are opportunities to grow. What is holding us back in many cases is, in fact, the absence of infrastructure to securely manage health data. So, people have been doing this on individual research groups, but it takes a lot of effort, and so they haven't been able to get that done. And that essentially has cut us off from the very large National Institute of Health grants. And so we estimate that the absence of that research over the next decade is probably going to cost Florida State University somewhere between $750 and $1 billion, $750 million and $1 billion in lost research revenue. So we think this is a big problem, right? It's not just a problem for health. It's also a problem for human subjects, although those data sets tend to be smaller, and the amount of money involved tends not to be quite as large, but in some cases it can be. So there's the research opportunities and the need for more health research on campus. The other issue that most people don't realize because of the way FSU is organized is that about a quarter of FSU's graduate students and about a quarter of FSU's undergraduates are getting their degree in some health-related field. Right? And you'd never know that if you look around and say, well, where's the College of Applied Health? There isn't one. right? But yet it is a very large component of what goes on at the university. And so again, if you look at what are the things that those people, when they become graduates, are going to have to deal with, a lot of it is going to be data, guided practice. And so they're going to have to figure out how, they're going to have to know at least what the heck this big data stuff is all about, because decisions are going to be made that will impact them based on that. And so FSU concluded that we somehow needed to produce some infrastructure to help solve this problem. And so the Vice President for Research put together a small task force to say, look at this problem, come back and give me an answer in 2 months. Okay? And so Jim Clark, who was the Dean of Social Work, headed that committee, and there were about 8 members. And we looked at the problem, and we said, well, we're not going to solve this in 8 months, because this is a serious problem with the university's limited capacity to help support research, computing, and data management. And so that is essentially where we started. We started with that conclusion, and so now we brought in the American Association for the Advancement of Science and some other people, talked with a bunch of people on campus, and every time we talked to people, we discovered new problems. And so we started looking at, okay, how do we deal with this? And that's kind of the story I want to talk about, right? And so we essentially, as a result of that first group, what we recommended was that the university try and figure out how to solve this problem. And we came up with a conceptual design of what were the things that were needed, including really the creation of the technical infrastructure, but even more importantly, the creation of the expertise to help support that kind of research. And everybody that we talked to has said that the hardware doesn't matter if you don't have the expertise. So you got to figure out how are you going to get a group of people who understand how to manage large data sets for research, how do you get information out of those, how do you manage them over the long term, how do you publish them, when do you delete them, how do you delete them. All of that turns out to be to matter. And so that first task force really, that ended in December of last year, really tried to identify the problem, lay it out in detail, and create a conceptual design or a conceptual solution for that. And so then we created, as a result of that conceptual design, we realized that we had to build essentially a research information system at the university that didn't exist. And when I say system, I mean people, processes, facilities, all of those things that go into that. And so, as a result, the university created a second task force in, I think it was March, or maybe it was April, something like that. And our goal is really to engage the university, the entire university, in solving this problem, because it's going to take the Office of Research, it's going to take the colleges and schools, it's going to take the Institute, or the Information Technology Systems Group, it's going to take the libraries, it's going to take a whole range of people trying to solve this problem to get it done, and then actually going forward and creating the solutions. But of course, the first problem you run into when you're trying to create a solution is really being able to understand the problem. And so understanding what are the difficulties that people are having specifically, identifying the use cases. What are people going to use this for? Right? Because otherwise you do all this work, you put a lot of time and money into it, and nobody uses it, and so you wasted all that. Right? So the key issue in all of this, and the thing that will ultimately lead to its success and support, is whether people use it at the end of all of this. And so if and it's pretty directly tied. whether you're going to get money from the provost or the vice president for research depends on how many faculty are telling them they need it, and how many graduate students are using it. And those kinds of things end up mattering almost above anything else. So, again, just quickly, I sort of already said this, but we have been, we talked with focus groups, we learned what other universities are doing. We maybe talked to about a dozen different universities about how they were dealing with this problem. Some of them, had said they're really in the same place where we are. Some of them have been doing it, but they don't like what they've been doing. Some of them have done things that they like, and so we've been trying to do that. We brought in 3 experts from around the country who are running university systems that provide some of these services, and asked them to review us and where we were and recommend a plan. And then we took all that information and came up with a conceptual solution. And for those of you who've been involved in the Innovation Hub, this is kind of a classic design thinking problem. And where you're really trying to figure out, developing an understanding of what the problem is, trying to define it, and then we get into the next part of it. And so that kind of initial involvement said, okay, we've got to increase competitiveness and opportunities for NIH and other funding. And that really is, really to grow a graduate program, you have to have money to support graduate students who are coming here. And quite often that means that money is coming from research contracts. And it's really getting graduate students involved in what people have identified as the most critical challenges of our time. It's things that other people at other universities and the National Institute of Health have said, this is important, we need it solved, we're going to spend money on it. And by doing that, we get graduate students who are engaged in solving those same important problems. Right? We realize we have to develop a reliable, efficient, and secure system. And so that means that we've got data that needs to be protected. And so we better be good at that. We've got data that people rely on over a long period of time to do their research and to generate their own income and their own, develop their own research agenda. So it better not go away. It can't be, oops, we lost it. You can't do that, right? And so, that reliability, and it needs to not take all their time to do it. And that's another thing. It's easy to come up with a system that takes a lot of time to do this. I mean, I'll give you an example from my own research. When I was working in physics, one of the problems that we were having is that we were generating about 1 terabyte of data a day when the computer systems couldn't address any file larger than a gigabyte. Right? So, or 2 gigabytes, I'm sorry. So we needed 500 files a day that we had to do. And being able to manage those files depended critically on assigning the appropriate metadata to that data when we took it. So we could find it later on. Right? We've got 450 people trying to sort through this data. They got to have a good way to find it. If you work out the numbers, we acquired 1 2 gigabyte file every 50 seconds. So if we were going to assign metadata to that, it better not take very long. Because every minute we spend, we're cutting our data in half. Right? And so you have to have something that gives you the necessary metadata, but doesn't take any time. And that's a tall order. But anyway, so that's something that we've got in mind. We really have got to make sure that we build in the appropriate student experiences, that they get the education and the training that they need to be able to manage all this data. They get the opportunity to work on these really world-class problems. And at the same time, we want to increase faculty productivity on useful things, right? I mean, we can have them fill out forms all day, but that doesn't that doesn't help us generate the revenue that we need to run this operation, to be able to support graduate students, to be able to offer our classes. So anyway, that's what the recommendations were. The second task force came back and said, okay, given all of that, what are our goals? What do we have to accomplish? And if you've studied project management at all, you know that the very first thing you have to know is why you're doing this. And you have to get buy-in from the very top level of your organization as to why you're doing it. So we had the provost and the vice president for research evaluate all this stuff and specifically say, here's some of the things we think we could be trying to accomplish. What do you think? What do you act? And so they said reliable, easy, and in demand. That is something people want to use. We need secure, auditable storage. We've got to be able to tell the Food and Drug Administration, we've got to be able to certify that none of these documents that we've stored have been changed since they were stored. So you've got to be able to say who accessed all this health data. And you've got to be able to do that on an individual file basis, on an individual level basis. And so it's got to be secure and auditable, both in the storage and the computing. When we say, okay, how much of this do we need? The first thing you realize is you don't have any clue how much storage you need 5 years from now. You don't have any clue how much computing resources you need 5 years from now. You can make some guesses, but it's going to evolve. And so the very first thing you realize is you have to build a system that can grow. And it has to be able to grow efficiently. So we have to realize that it's going to be evolving. The single biggest thing everybody wants is support. And one of the key issues is really the data, support for data and data management, data collection, data management. So that really implies a couple things, but it's critical that you understand the data life cycle for every experiment, which mostly they're going to all be different. You're going to have to understand really how you do the analysis of this stuff. And then, more than anything else, you also need a predictable funding source. And at this point, you ask, how much money does the university have for this? Well, the vice president for research has committed $2 million to get started. Now, if you haven't done these things before, you think that's a lot of money. It's not. Not even close. So, the task force said, you ought to think it's going to cost you $30 million. So we've got to figure out, how do we get that money? Right? And it may not cost us $30 million, it may cost us 15, it may cost us 50. So we've got to figure all that out. So that's kind of where we got to. And yeah.
On the first point there, where it says in-demand technology, what do you mean by the in-demand part?
What I mean is that faculty and students want to use it. You're not saying you have to use it. They're saying, this makes my life so much better that I want to use it. Okay? It makes it easier for me to do my research, so I'm going to use this rather than anything else I could do. Running around on my laptop or whatever else I want to use. Okay? That's what that means. And none of those things are easy. And so we have put this group together where we've got a whole bunch of task force now, or a task force and subgroups. One on technology, one on community building, one on the research agenda, and another on funding, that are trying to figure out how do we solve this problem in general. And so, plus we have a steering group that's really trying to help organize all of that. And at the current time, one of the things we're trying to do is evaluate and determine just what people want to need, right? And so that is really a collection of going out and talking to people, getting them to tell us or write down what it is they need to use this for. What are the challenges they have now? What are the challenges they think they're going to have? What do they think the solutions are? And so we're going through that process. And so that essentially is what I said here, right? It's just we've got this infrastructure in place that's trying to work through this problem, and we think it's a multiple-year task, right? I mean, just roughly, here's kind of where we are right now, where we're really doing preliminary designs. We've got a whole bunch of pilot projects ahead of us moving into operations. And in the whole process, we're using pilot projects to help us solve specific kinds of problems, to help educate us about how to solve the next group of problems. And ultimately, then being able to help faculty and students onboard their project and be able to do all this stuff. And so, the way this works is, in terms of our thinking about it, is we're really doing discovery, design, and implementation over the first couple of years, and then we move to operations sometime between 2021 and 2022. Again, this is just a rough estimate, and we're starting already trying to get the community engaged in this, and telling us what they want, what they need, what they don't need, what they don't want. And then the Health Data Science Institute is really just getting started in its planning, which is really focused on the research aspects of that. And I'll talk more about what's involved in that in a bit, or what we think is involved in that. But when we think about creating this information system, these are kind of the constraints we're operating under right now. And so, we're currently seeking a project manager that will help us work through all of this. Right now we have a poorly trained and not very well exercised one that's trying to do all this stuff, but we're really looking at who are the people involved, what are the organizations on campus involved, getting them all talking to each other and trying to think through the problem from their perspective, getting the technology, looking at computing, storage, networking, software, and end user support. How do we support the people that need to use this? And so, if you look through any of the cost models or how you might fund this, you realize that this is probably the most important part of this whole thing. That if we can't encourage and support users to use the system, we don't have enough money to operate it. So it doesn't matter. Right? So, and like I say, what we've got is right now $2 million. We're talking about more than that, but I'm talking about the Vice President for Research about more than that. We've got about 3 years to do it. And so from a project management standpoint, that's kind of where we start. And so I want to spend a few more minutes talking really about the health data information system. So really trying to look at how do we work through that. Again, you're looking at a system where you can't predict what you're going to need 5 years from now. And so you've got to figure out how do you build flexibility into that. And always the answer to that question is you start with as flexible a set of standards as you can possibly think of that will do the job. And you build everything, you think through those standards, you use and develop based on those standards. And so in the end, if you develop a system for the collaboration that goes on in these research groups, and somebody says, this is terrible, it stinks, nobody can use this, I can't understand it, you can say, well, here's how you build your own and plug into it. Okay? And, so we're looking at all kinds of things like a user interface that starts with just a command line interface to a web-based interface to a standalone application that could plug into this. And so we have developing standards for a lot of different aspects of that. We kind of focused on, at this point, the technology really building into what we call a replicable and scalable secure enclave. And that is a way of building a computer system and storage system where the data is secure. You're able to manage what goes in and what goes out, who accesses it, who doesn't. Although for the most part, almost everything that people do with these systems is dealing with the metadata. It's only rarely that they actually move and touch the data. And so a lot of the collaboration can be built entirely based on the metadata. And you can find out a lot of information about a file and where it is and when it was produced and what's got in it by looking at the metadata if you do the metadata right. And you only have to worry about actually getting the data when you have to grab that file, run it through some applications, and produce something new. So anyway, we've been looking at all of these aspects. And again, we keep coming back to the same issue, is the meeting user needs determines your long-term system support. So you better do it well. And so we are really looking at two aspects of this. One is the secure computing and storage and transfer of data, but the other really is the collaboration support for students who are working with their major professor and their committee on data, for research groups where there are a bunch of people taking data, other people analyzing it or processing it, another group analyzing it and trying to extract science from it. And so that's kind of what this whole thing looks like at a very high level. It really is got some secure storage and computing resources. We haven't said how we're going to do that. It's got user interfaces that access the metadata, publication interface that will pull some of the data can be public, as well as the metadata out to it. And then you're also going to almost always data is going to get here not from inside this system, but from external sources. So it may be a clinical trial that you're giving people wearable devices to try and reduce their weight. And so you're looking at you're collecting data from all of those wearable devices, and that becomes part of somebody's medical record, actually, and is also being used for research. And so how do you deal with all of that external data? And so in a general concept, that's what we're looking at. And so then we said, okay, what are the standards that we have to identify here? And so, first of all, we said, okay, if you think about a file system that you have on any given computer, it's got file names, it's got directories, it's got who has access to it, it's how big it is, data's great. All of that is really metadata about the data, right? And so what we need to do is extend that. We need to extend that so it says, what device was used to collect this data? What kind of data is it? Is it genomics data? Is it processed genomics data? Is it what are the things that are there? And how do we let people do that on a case-by-case basis? And so we've really tried to focus on extending that metadata so we can automate the management of everything. Again, we'd like to not have to have people do this by hand. We'd like to be automated so that they can set it up and start it running, and it tells them when it was successful and it tells them when it failed, and they can deal with those things. All right? And so, and make sure that they can find it. I mean, that's again a huge problem in all of this, is once you've got, in our case, once you've got 250,000 documents that you've accumulated that are all these files, how do you find the one you need? Okay? And so, traditionally what everybody did was they developed directory structures. That directory structure was their extended metadata. But it's not the best system. Right? And so we're looking at that. We're also looking at user interface standards and recognizing that, we're going to have command line access to this, because almost all of these high performance computing systems are using a command line interface to do the calculations. And so you're going to have to go to that level, but it also gives you a good basis or foundation for developing test cases that can be replicated. We've got web and database interfaces that you also have to deal with. You know people are going to want to be able to access a database to pull all this stuff out, create their own web application. You may also want to create a web application for them. And so, and then we've started thinking, okay, how do we build this enclave? And so one of the things that you find is that for data that for the most part, when you've got large amounts of data, you're not doing daily backups, you're not doing incremental backups, there's too much data there, right? And so essentially you're writing it once and not touching it until it needs to be deleted. Now we mirror it, right? So that's how you try and protect against system failures. So you create a copy, but you write it once, and then you don't get rid of it until somebody definitely says this has to be deleted. And that's kind of our approach. We have a transaction log that says, did anybody want to look at this data? Did anybody request it? Did they succeed? Did they not succeed? All of that stuff has to be kept. Then we've identified clear, limited actions that people can do within this system. And I'll talk about those in just a little bit. And then finally, we think that one of the benefits that we can provide is that, we can say, okay, here is a good way to manage human subjects data that's collected through surveys. You don't have to do an IRB for that. You just have to say you're using this one. And so that then starts to hopefully reduce the paperwork required. Because somebody has worked that through and everybody else says, yeah, I'll do that. And so again, and I think the other one that we're looking at is trying to make sure that we can automate publication. We may not do it all the time, but that there is a well-defined path for taking the data that should be public and making it public and making it available. And also making it findable. Yeah.
So, still trying to get my mind around this a little bit. So,
sure.
So two questions. One is, you have all kinds of possible data, right? You have video, you have heart rate data, you have, just all kinds of whatever.
Yeah, you have no idea what you're going to get.
Okay, but you're not taking the data until the point where they have a complete set. Did I follow that correctly? Like, you're not just constantly...
Well, it might be an incomplete set, but it is something they said, we've collected this data, we need to make it secure.
Okay, so they're collecting it for a while first before it comes to you in
whatever. Maybe not.
Okay.
So how do you do multi-state clinical trials where you're collecting, just something as simple as REDCap. REDCap is a web-based application that lets people enter medical information related to a particular clinical trial over a secure web interface. Okay. So a lot of people use that for these, they give it to a clinician and they say, have somebody in your office fill this out for these patients. And so, you could collect that externally on Enclave, or you can find a way to build that web server inside it. So when we talk about the computing that goes inside this thing, we're not thinking it's just one monolithic system. In fact, most universities have multiple systems. They have supercomputers, they have virtual computers, they have web servers, a whole range of things that are inside that secure system. And what's managed about it is not everybody can get to that computer, right? And the individual users can't go in and look around at other people's files and all that sort of stuff.
So that's going on, and this is also the point above that, where now what is accessible to people can be pulled out and published and all.
And publish it, right? And so one possibility, the simplest possibility, is you built a web interface that says, here's how the researchers are looking at all their data and accessing it. Well, so you basically replicate that interface, but only provide the public data to it.
Right.
And you might provide the metadata about the non-public data, just in case you think there's a possibility that somebody would discover that and want to get back in touch with you. But so that would be the easiest way to do it, I think. Now, other people say, well, no, we really need a custom tool to access any of these data sets, and I say that's fine until you have 50 of them. Okay. So anyway, I think that's a critical issue for us. And yeah, all the thinking we can get on that, we would love to have, right? I mean, a lot of this, I think, yeah. So I mean, this just sort of shows what we're kind of thinking that makes up this secure enclave, and really there are, we know we're going to have to bring data in. We know we're going to have to take data out. That you may be taking data out because you've got all these functional MRI images that you need to send to Oak Ridge to process on their supercomputer. So there may be whole ranges of reasons why data has to come in and out. But we know we've got to do it. And so what our scheme is to use this to define kind of the business models as to what can go in, where it can come from, who it can come from, what can go out, where it can go out, who it can go out to. So that you basically have said, oh, well, Oak Ridge has verified that and signed a contract with us that says they will manage this data in a secure, HIPAA-compliant way. And so, and then again, all at the same time, you have a transaction log, you've got storage, you've got data analysis from sources, and you're using some kind of electronic notebook really to interact with all of that, to keep track of the data, to launch applications, to look at the results of applications, to direct the flow of data, and to track what happens. And so this is really intended to be a kind of a high-level user's view of what's going on with their data. And again, any one of these things is complicated. Put them all together, it's a lot of work. But it's straightforward. It's not impossible. So anyway, so we have a whole bunch of different components of this, why they're there and what they provide for us, which is really what we're trying to communicate to people and lay out the whole process. You put that on a bigger system, and you really want to be able to replicate that, so that this essentially that interface is kind of your virtual desktop into this thing. And it might be as simple as you're using a single computer, or it might be a situation where you're having to use high-performance computing systems to do all this stuff. But we essentially want to try and take the same model and replicate it across all these different kinds of platforms. And again, give people an easy and well understood way of getting access to it and doing all of this stuff. So, this is just one approach. This is really the first one that we're just starting to talk to people about, and so they can tell us what's wrong and what they think are the problems there. Where we're saying, we've got to set these standards for metadata. We know we've got a document now that describes what we think those are. We've got to create options for the interface from command line all the way through to a web interface, and then be able to basically deploy these virtual desktops so that they can either run the computations on that virtual desktop, or do that to communicate with the supercomputer or other cluster system to do the computations they need to do. So that's kind of where we are. And we've identified really some core objects. and we keep adding to those. Some of them are not really objects, in my mind. So the core ones really are really users, the files, the projects, the locations where we're getting them from, and I would say really the system object that describes things that the system maintains about all this data. The rights, what are the requirements for accessing this data? Who has clearance to access that data? What software has clearance? What systems has clearance? That all has to be tracked, but I think it's more attributes of locations and projects and users. The publications, again, I think that's mostly going to be a separate external system where you copy data out to it, but you want that process to be automated. And then we know that somebody is going to come up with more that they want, and so we've got to figure out how do you make this whole thing extensible. And but when we get really right down to it, we look at what are the actions that we let people do. We let them create data here. Some people, under some circumstances, we let delete data. Now, why is deleting a problem?
Somebody else may need it.
What?
Somebody else may need it.
Yep, that's certainly true. That's certainly true. And in fact, in this particular case, that somebody else might actually be the owner. All right? So, who paid for the data? Well, if it was the NIH, they said, man, that's not your data. That's our data. You can't delete that. Or you have a graduate student who gets their degree and goes on to move to another university. When can we delete that data if they didn't? Oh, that's all a tough problem, right? So you got to have processes in place to deal with those kinds of things. And so create, delete, and then send it to someplace else. Those are the three things that you can do with the data. And then when you look at metadata, well, you get to create it in some sense, but in another sense, it's all created system-wide automatically anyway, so you can update it. Right? You can change it. Some people can. You can view it. Again, some people. We're thinking that it depends on, again, one of the other big problems is who gets to see all this stuff. And under what conditions do they get to see all this stuff. And so we've identified and are trying to manage that based on a small set of standardized roles for people. And so, basically what we said is there's no data in this that's not associated with a project. That's first and foremost. It's got to be associated with a project. Secondly, that project has to have a lead. At least one. They have more, but it has to have at least one. Now, suppose that lead leaves for some reason or other. And there is no lead here on campus who has access to it. Well, essentially that's where the administrator has the ability to make themselves the lead on a project if necessary. Then that project lead can make people members of that project. And those members quite often will have a lot of rights, but they can't add and subtract people. And then there'll be people who will guess. And again, we haven't sat down and said these are precisely the default abilities of guess, but mostly we're thinking that they can see the data. And then, of course, you want to be able to customize that. And the other one we've added to this is really what we call the archivist. And the archivist is really the one who's ultimately responsible for making sure that the data that gets published is published, the data that needs to be deleted is deleted. And so basically they have ultimately built into their role the authority to do that should there be nobody else available. So again, if there's a project lead, then then mostly they're doing it. But even a project lead can't necessarily delete data that's been put in there. I mean, you can imagine, you do these things long enough, anything that can happen will happen. And so you can imagine a situation where the project lead gets really upset with the university about something. And it says, I'm going to go in and delete all this data. Well, at this point, we're thinking they could request to delete that data. And normally it would be honored. It would just happen. But there would be another step in that process. So, I think we have a lot of, I could talk about this for a long time because I've been working on it for a long time. But I think, one of the things, we are trying to build out the team that works on this project. And there have been people that have asked to actually study us as we go through this to see whether we screw up or do it right or get it wrong or whatever happens, and see what they can learn from that. And that's a good thing because it doesn't matter whether we succeed or fail; they get something useful out of it. So, but we are looking. We began with a small group in June. We're trying to fill the technical lead role, negotiating with the person now, and again trying to identify and recruit additional key players in this whole thing. And so when you think about this system, it really is requiring us to change the university, right? And this is why I keep telling people, IT is all about people, not about computers. You got to solve those social problems. In this case, you got to change the way the university thinks it's going to operate, and you got to change a bunch of people. And if you don't do that, none of this is going to work. And so this problem really does come down to: can we get the Office of Research to think about computing differently and their support? Can we get ITS to think about it differently? Can we get the library to think about it differently? Can we get the colleges to think about it differently? Can we get the provost to think about it differently? And ultimately, we got to get our president to think about it differently so we have more money. And there's more money directed towards this activity than some of the other things we're doing. So anyway, that's where we are. I'm right in the middle of this and glad to talk to you about any aspect of it anytime. Right? Yeah.
Do you have the pilot 1 and pilot 2 in place? And if so, what are those?
We have the plan. We have a group of, we now have some applications for those pilot projects that we're evaluating. And so the issue with the pilot projects is we're not really evaluating the quality of the projects, we're evaluating their match to our needs, right, and our capabilities, because they could have really great projects, but we just don't have the capacity to deal with it yet. But so one of my tasks for this weekend is to finish reading and evaluating all those pilots. And so yes, we have that. We have all the data from the collaborative collision, where everybody did a poster that said what their project was, what they had expertise in, what they needed, what they thought were the opportunities. And so we're going through that, evaluating these 100 or so posters about what these faculty said they needed. I'm trying to think. We've got some, again, earlier focus groups. The library's been doing some focus groups on data management, data lifecycle support. We've got some really interviews with a whole bunch of people who use high performance computing on campus and what their needs and challenges, and so we're trying to bring all that together and make some sense of it. And it'll take us a while. Yeah.
Is the project will require the data producer to follow certain data management plan or template?
Yeah. So require is maybe too hard a word, right? So everybody that's producing this kind of data already has a plan and a process in place. But they're having to develop that plan, manage that plan, and document that they've met that plan on their own. And so what we're trying to do is figure out which of those plans are generally useful and figure out how to implement them so that lots of people can use them and different people. You go, like University of California, Berkeley, you go to their website, it's pretty advanced on all of this stuff. What you'll find is they've got 25 data management plans, different data management plans. And they say, if you've got data that fits these categories, you might want to think about using these plans because then you don't have to do your own. Right? And so that's kind of what we're trying to do, is to help people think through those plans without having to develop them from scratch. But I don't think we're ever going to be in a situation where we can require anybody to do anything. I mean, first of all, we don't know the details of what they're doing, and there may be very unique circumstances in theirs. And so what we're really trying to do is offer them some options. I think that's. But yeah, so that's you look at you ask yourself, how does the university manage the security of human subjects data that graduate students are collecting and using for their thesis? Well, who has to develop that plan? I mean, who develops the plan for managing that right now? Graduate students and their major professors, right? Who has to manage and implement that plan? Graduate students and their major professors. Now, okay, it's useful technology to know in most situations, but is it really advancing your education or your dissertation in information because you know how to develop those plans? So we're trying to, and you take it even further afield. If you're a biologist, is that really helping you advance your understanding of the human genome and its relationship to diseases, or is it just another piece of equipment you have to maintain? And so that's kind of how we are thinking about it and trying to convince people to think about it. Now, they may not, but yeah. And that's partly what we mean by in demand. We can say something, well, yeah, you can develop a plan, go through the IRB and do all that sort of stuff, or here's one they've already approved. If you can use that, use it. If not, fine. I mean, that's kind of what we're after. Other questions, comments?
So, I see as part of this that they talked about a Health Data Science Institute.
Yes.
Is that part of the conceptualization here, or is that really kind of farther down the road?
Let me see if I included any of those slides here. Yeah, so there is a research team that has about, 20 faculty on it. They're looking for more. That's developing that plan. I would say they've really got they've really identified 4 areas that are kind of broad. One of them is clinical and behavioral health and the life sciences related to health. Or health related to life sciences. And I can't for the life of me remember that 4th one. sure it's on.
Yeah, I was trying to see.
It's on the website, I'm sure. And let's see.
So the 20 you have are starting to make up these pieces of the Health Science Institute.
Yes. And so they're starting to try and put that together. Let's see if it's in this. I don't know where I put it.
I got this one.
No, that's not the one. There's one graphic. I think I know where. Sorry. So this is why I'm convinced that directory structures don't work as metadata system very well, even though they are one. Yeah. Okay, so I guess that first one they got was actually two. I was remembering it as one. So it's really the clinical, behavioral, and community health. The life and medical sciences is the fourth. Let's see if I can get this on the screen. So this is kind of how we envisioned the whole thing conceptually within the first task force was a Health Data Sciences Institute that had four main research agenda. The ones that you see, the life and medical sciences, clinical, behavioral, community health, responsible data management, social science, and public policy. And then trying to come up with the cyber infrastructure that had, the high performance computing and storage, the whatever HIPAA and human subject data computing and storage was required, any data lifecycle support and visualizations. Those were the things that we identified as key. When I think about data analytics, I'm always thinking about really 5 things that you need to know about. You need to know about data lifecycle management and databases. You need to know about programming. You need to know about statistics. You need to know about visualization and visualization communication. And then you need some domain expertise, right? And I'd say the one that everybody forgets all the time is the visualization component and that communication component. But you can do all this stuff, but if you can't tell the story as to why this works the way it does, you can spend all your time having no impact on people. So you really have got to be able to. Data science is complicated enough, and the process is complicated enough that you have to learn how to tell the story. And so it's really pretty critical that you get some of those visualization tools to be able to develop and tell those stories. Okay? Anything else? Okay, well, I thank you for your attention and your questions, and I'm happy to talk to you anytime about any of this stuff.